Good evening, friends. Welcome to Eastern Academy, and we are into embedded system programming. As a part of embedded system programming, we are into digital electronics. This is session 3. In this session, we are going to discuss about application of combinational logic. So normally we have a small doubt about what is combinational logic and what is application. We'll explain it today. And the last session we discussed about the fundamentals of digital electronics, that is the gates and or not, there's a basic gates. And the application of the gates is combinational logic. Today we're going to see the application of combinational logic. And application of combinational logic will get some components. And that will be used to build some other thing. This is the way that we build the whole system. I've already explained to you that how do we do that. We take a clay. From a clay, we build a brick. Okay. A clay is made a brick. And using a brick, we convert a wall. Using walls, we convert a room. Then room to the house. Then house to apartments. Then the complex. Then city. Like that we go. The same thing here. That's the way the whole thing is growing. Okay. So let me give you a small idea about this before we proceed into the application of combinational logic. Let me draw something how the things go. The trick here is, we know this is very simple one. A battery, a switch, and a bulb. This is a very simple circuit. Electrical circuit. This is a simple electrical circuit. We all know that. And you control this switch manually. That's what we have it at home. Everywhere, all the battery, everywhere we have this. This is the application of electrical. This is generation, transmission is current, and utilization, and this is control. And we can have a meter here. That's fine. That is for measurement. That's all about electrical. Now, sometime instead of switch, we use a variable, a resistor. We call it as a regulator. Switch have on and off. Regulator have a continuous growth. Continuous is regulator. Then people have, what they did was, they have moved the control alone separate. See that? They moved the control alone separate. There's a switch or a regulator. But they control through voltage. Please understand, instead of controlling by hand, I used control through the voltage. But you know one thing, to do the two activity, they found a single device called transistor. So transistor can be a switch or transistor can be a regulator. Switch or regulator. When I use a transistor as a switch, I call gate. When I use transistor as a regulator, I called amplifier. Understood? So now from electrical, we have gone to electronics. Electronics is the one, you control the electricity by electricity. That's why normally we know mathematics, physical, physics, mechanical, mechanics, optical, optics. All the X are basically the input-output relation. That's called Y is equal to F of X. That is what all the X. Same way electrical, electronics. So what we have moved from electrical to electronics. So we remove this. So in electronics, we have two things. It's a voltage and control. We have a gate or amplifier. This is digital analog. Now, the application of gate is AND function, OR function, and NOT function that we discussed yesterday. Am I right? And using this, I can do a lot of things. But one of them is combinational logic. Please understand how we do that. We have a small electrical switch. Then we take only one portion. We have gone to electronics, that is control, automatic control. So automatic control of electrical is electronics. In electronics, it's a two portion. One is gate, I can use as a switch. Another one is amplifier. And in the application of gate is AND, OR, and NOT. And using this, I can do a lot more logics. I'm going to do one of them is combinational logic. And today we are going to discuss the application of combinational logic. So this you should know the path, how it came. And combinational logic is very simple. I have a block. I have a name. I have a name. This is what the name in binary word. So 1101, that means 6 inputs. 11001. So 110011. That's all. If you know that, you're done. You'll be very. See, the problem is we have a problem. We get confused between combinational logic and application of combinational logic. I'll explain to you right now. What is application of combinational logic? If I tell you the thing, then you will surprise. That is, this is combinational logic. The application of combinational logic is adder, subtractor, encoder, decoder, mux, demux. Let me tell you one important thing. In 1970s to 80s, that's a period that digital electronics start picking up. Till that time, analog was the only electronics in the world. What happened was, this is the last. So in the college, everywhere we have been studying, we have to discuss this. Understood? But today, see, you know that about 100 years back or 200 years back, people thought only sun is the biggest star. But that's the reason we thought, oh, sun is great, such a big, and the earth and everything is small. But today, when they find the galaxy, out of the big stars, the big star is this much, the sun is become too small. Now sun is become too small. Like that. What happens today? These things are all become too small for the industry. Nobody bothers about this. But still, we will as a part of it, we will discuss today. The most important functionality we'll take adder. We will take adder. And we will build the adder using combinational logic, what we discussed in the last session. How do we build it? See, there are two methods of doing the problem. One method is every problem, you will solve it with a unique way. This is called old school. This is called old school. What is a modern school? For every problem, there is one generic solution. Generic solution. Fit the generic solution for every problem. So we are going to fit everything into the one combinational logic. What is that? How are we going to do that? That's a trick. Please understand, how are we going to do the generic solution? What is a generic solution? We discussed one combinational logic, multiple inputs, one output. Other one is multiple inputs, multiple outputs. That's the maximum. N inputs and M outputs. N inputs, one output. Am I right? This is what we discussed in the last class. If you watch the videos, if you have That will be fine. Now, what is adder? How do we add? We have 7, 8, 5, 3, 4, 6, 2, 1. We try to add. 3 plus 1, 4. 5 plus 2, 7. 6 plus 8, 14. Put 1. That's the 8 plus 4, 12. We add it. So we are taking 4 digits. The result is coming as a 5 digit. Result can be 5 digit or 4 digit. That's fine. And we don't add 3 digits. We actually add 3 digits. 1, 2, 3. Sorry, not single. And this is called number A. This is called number B. Number A is having 4 digits. If I say number A, third digit, that is 8. Number A, fourth digit is 7. So what we do here is simple. In the school, this is very important for us to understand, because the problem is this is called scaling up. If you know by a generic method, you can scale very big. So in the schools, they teach you 2-digit addition or 3-digit addition or 4-digit addition. But they never teach you 20-digit addition. Am I right? They never teach you 20-digit addition, but you can do it. You can do the 20-digit addition. That's a trick. They taught you 4-digit, but you can do 20-digit. You'll be very surprised. When my son was in the school, once the teacher taught him, you know, once he came home, he said, "Daddy, I want to do 100-digit addition." 100-digit addition. He sat with me. We took a printout on the paper. We put it on the wall. All the numbers. And he did a 100-digit addition. Then he went and told the school teacher, "I did a 100-digit addition." That's the way you should be. Now, let us go to the binary. The binary, I add 1, 0, 1, 1. 1, 1, 0, 1. That's all here, 1, 1 only. You are adding 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 1, 0. Am I right? This is very simple. But let us make it how I'm going to analyze that. I'm not taking it like this. I'm taking only 1 digit. And I'm going to duplicate the same thing to all the people. I'm going to duplicate all the thing. This is called bit 0. This is called bit 1. This is called bit 2. This is called bit 3. In decimal, we call digit. In the binary, we call bit. So bit 0 to bit 3. Am I right? Now we are trying to add 0, 1, 1, 0, 0, 1, 0, 0, 1, assuming. Now I will add a number here, A, B. A is having 0. Sorry, I'll have one more. 0, 1, 1, 1. And B is having 1, 0, 0, 1. So A is having 4 bits, B is having 4 bits. Now what am I adding? 1 plus 1, 10. But I put 0 here. I put 1 here. Then I add 1 plus 1 plus 0. But see, here I'm adding 2 digits. Here I'm adding 3 digits. How do I make generic? So what I did was I add a 0 here. I'm adding 0 here. Then 0 plus 1, I get 0. The 1 goes here. Carry. 1 plus 1, 0. The 1 goes here. 1 plus 1, 0. The 1 goes here. So now what happened? It's very simple. If I do the same thing in your block, see here, I do same thing in a block. I have 4-digit number, 4-bit number, A. See here, A, B, and sum, and carry. Do you understand that? Now I got 5 digit. I have 2 digit. I'm giving to the box. This box is going to give you the output. Now what you did here, bit 0 of A you added, bit 0 of A0. So we can write like this. Let me write this number like this, not to confuse you. I say that A0 A1, A2, A3. B0, B1, B2, B3. Then C in 0, C in 1, C in 2, C in 3. Am I right? Because we have carry in. That's also coming to the adder. But this is always 0. Understand? First one is 0. Because when you add any digit, 1, 5, 6, 7, 7, 8, 9, 3, you add only 2 digits. You don't add the third digit. But we assume it's a 0 now. Because I want to make generic everything. So you understand this. You make only one block now. I take only one block now. Okay. Now this is B3, B2, B1, and B0. And this is A4, sorry, A3, A2, A1, A0. And this is S0, S1, S2, S3, S4. Sorry, carry out, C out. So try to understand these two blocks. How do we do that? That's a trick. So I have a block called adder. This block takes 4 numbers and 4 numbers, 4 bit. That's why I put /4. This is A and this is B. And it gives you a sum of 4 and 1 carry out. That both together you get the final output. You can use any way as you wish. This, if you expand it, we call this as a 4 inputs. A1, yes, A0, A1, A2, A3. B0, B1, B2. This will be very useful when you are trying to understand about ALUs within the microprocessor. That's why I'm explaining now. And the output is 4. This is sum. Carry. Sum 0. I've already told you that if I have a wire and if you put a slash and if you put the name as a D and I put 8, that means that if we expand this, it becomes 8 wires. D0 to D7. This is LSB. This is MSB. If I say a number is 76 as hexadecimal, 7 means 0, 1, 1, 1. 6 means 0, 1, 1, 0. Am I right? This is the way we expand it. So these are all very simple things, but this will give you a lot of advantage when you are trying to understand the whole system. The whole C. Once again, I'm telling you that 80% is C programming. Please understand. 80% is C programming. But this knowledge plus this will give you the superb edge. A computer science or IT or MCA student can learn C programming. But what the core industry wants is a person with the C programming plus this knowledge. But very unfortunately, 90% of the ECSE students cannot get into the core industry because you underestimate the C programming. That is a very easy, but you don't practice. Same way, this is very simple. You always complicate because your syllabus, the books were written about 30, 40 years back books. And those days I told you that the biggest was digital electronics. So they will give you a page by page digital electronics, but nothing is required. I'm telling you, even this is not required. Only thing you have to remember is this: combinational logic. So many inputs, the name. This is sufficient. Even I will tell you, I'll forget this. But as a part of a small understanding, I want to tell you that what is the application of combinational logic. That's what I'm giving you now. Now, in the school, first they teach you 1-digit addition. Like that, what I'm doing, I'm going to take 1 digit. Now, how do I do that? If you have to have 1 digit, every digit have 3 bits. One is carry in. One is A. One is B. One is sum. One is carry out. Am I right? If I add a number 1, 1, Then 1 plus 1 is 10. That time I get a sum, I get a carry out. And here two numbers, but we first digit alone, we are assuming 0 is a carry in, first digit. So we take this common. Now the trick here is, so now I understood. This is what I have to design. See that I have to design now, yeah, block of 3 inputs, A, B, C. There's C in. And we have out to call sum and C out. This is a first application, 1 bit adder. We are adding a 1 bit now. Now, how do I design that? That's a trick. What you have to do is, you have to draw a table immediately. That's a very important. You have to draw a table. You have to draw a table. And the table has inputs. Okay, now let us mark the outputs. So this is output. 2 outputs. Okay, now the input is A, B, C in. The output is sum and carry out. Am I right? Or let us give this also sometime, not confused. A, B, carry in. Let us assume. Now, if we want to add, all the numbers are 0. All are 0. 0 plus 0 plus 0 is how much? 0. So both are 0. Now A is 1. 0 plus 0 plus 1 is 1. 0 plus 1 plus 0 is 1. 0 plus 1 plus 1 is 10. That is 2. 1 plus 0 plus 0 is 1. 1 plus 0 plus 1 is 1. Sorry, 2. That is 1, 0. 1 plus 1 plus 0 is 2. 1, 0. 1 plus 1 plus 1 is 3. 3 means 1, 1. Do you understand this? Do you know from here to the table? That is very important. You should be able to draw the table. This is the requirement. 1 bit adder. What is the application? The application of combinational logic is 1 bit adder. Do you understand the 1 bit adder requirement? This is called requirement. And this is block diagram. And this is the table. This is called truth table. I'm not using corner map or anything. Please don't worry. When the moment you see the table, you get, I know that, upset. But I'm not going to do that. Do you understand this? If anybody don't understand, let me know here. If anybody don't understand this, let me know. Please. Now, what we are going to do is, the table is a first stage. From there, we're going to create it. Let me remove this. You know one thing, the table, we are going to remove, we're going to take out like this, 2 portions. C out separately, because 2 outputs. I'll take one by one. I will take only the C out. Sorry, sum first. Sum is having how many? 1, 2, 3, 4 ones are there. So I'll put a table now. See here. I draw a table. See, this method looks to be very difficult for you initially, but it became very easy once you practice. I have a C in, B, A, and sum, which is having 1. I'm not bothering about 0. I'm bothering about only 1. 0, 1, 1. Then 0, 1, 0. Then 1, 0, 0. 1, 1, 1. Because only for all the 3, we have 1. All the 4, sorry. Now this is called, this you can call sum truth table. Okay. Now what we are going to do, we are going to create another table. In that table, it's all one. Sorry, sum is one. Then we have a C in B. Sorry. B, A, and C out. Now 0. Sorry, what is it? Where is it? 0, 1, 1. 1. Then 1, 0, 1, 1. Then 1, 1, 0, 1. Then 1, 1, 1, 1. Am I right? Now you don't need this. Now you can remove this. This table is not required. You have done it. This is called C out. Now two tables you have created, only sum. Now let us first solve this. Now let us solve this. Now what happened? I have a block. I have a block which has 3 inputs. What? C in A. Sorry. Let's try to take this. A, B, C in. The output is only S, not 2 outputs. This we are doing only this block. Now there are how many combinations? 1, 2, 3, 4. I make 4 blocks. See that I make 4 blocks. Since we have a 4 combination, we make 4 blocks. And we write them like this: 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. Am I right? Done. Now you take this output. Let me draw it bigger. We take this output. We put a OR gate. This is called S sum. So from this table, I've drawn a diagram. You understand now. I put a OR only, but I didn't draw this one inside. Now you know that how to draw this. If I take this 1, 1, 1, I put just an AND gate and out. That's it, done. And if you want to do this, 0, 0, 1, 0, 0, 1, 1, 0. You understand? These are all called combinational logic blocks. You have 4 combinational logic blocks. Whenever all the 3 inputs are going inside. All the 3 inputs are going to everybody. So we connect to everybody. So all of them are going to listen. If you want to draw that also to be drawn, I will draw it now. See that. Now this guy is having 3 inputs. This guy is having 3 inputs. Now outside is 3 inputs. What we do is we take this one input, connect it to everybody. Done. Then we take the second input, connect it to everybody. Then we take the third input. We take the third input, connect it to everybody. Okay, now it is done. So if I give here 0, let's say A, B, C in. If I give 0, 0, 1, it goes to everybody. But this matches only this guy. So this become 1, all the others become 0. So since 1 is 1, this become 1. If I give 0, 1, 0, this guy becomes 0 now, but this become 1. So this become 1. Now if I give 1, 0, 0, then this is matches, this become 1, this becomes 0. If I become 1, 1, 1, all are 0 except this. So this become 1. This is what, yeah, you this now drawn a diagram for what? Sum logic. Now let us make that as a small block. 3 inputs and 1 output. We have already done. Now we don't worry about that. So this is same. Now we know that how to do that. 3 inputs, 1 output. Sum A, B, C in. We have done it now. Am I right? You have any issue now? Now I'm going to do this logic. This is also same. The only difference is the names are changing. 0, 1, 1. And next one is 1, 0, 0, 1, 0, 1. The method is same. 1, 1, 0. Then 1, 1, 1. Am I right? This is having it now. Now, if this inputs, this guy will become 1. This is called C out. So we have another logic now. Now understand, we have a big table. From that, we make 2 small tables. Then we created the 2 logics. Now let us do how do I integrate? How do I integrate? How do I do it is, I make 2 outputs, sum and C out. Then I take A, I take B, I take C in. There are 2 blocks. There are 2 blocks here. There is this blocks. What we have designed now. Now this goes independently, and this A goes here, the A goes here. Then the B goes here, B goes here. And the C goes here, C goes here. See, this is actually called divide and conquer. That's it. That's, you know that your problem has to be like this. If you start handling this problem, every combination problem is simple. You first of all should know that if you do, see, this is good logic, because you need to understand what is the input, what is the output. Today 99% of the students' problem is they don't understand what is the input, what is the output required. That is the thing. For example, if you go for an interview, what is required and what is your input to them? That has to be understood by you very clearly. Okay, what parameters they test you, that if you know that, then you will be able to give a right output. That's a trick. Everywhere, same thing. If you go talk to the customer tomorrow, you should know what the customer want. In the company, your manager is a customer. For you, your manager is a customer. The manager tells you what do you want, and you should give them output. So these are called building blocks. That's why I told you that. Now what I did was, from using the gates, we build the blocks, and we build the 1-bit adder. Now we don't need this at all. Now we removed everything. Now we have a 1-bit adder. So now what, like a school, what they teach you, now what I'm going to do that, see that. I have a 1-bit adder. This is a 1-bit adder. This has 3 inputs. One is C in, one is A, one is B, one is sum, one is carry. So if I add a number 1 plus 1 and 0 carry, I will get 1 0. This 0 goes to sum. This 1 goes to carry out, and this is carry in. This is A, this is B. Now what I'm going to do now is, how do we add now? In this case, first case, we make it to ground, because that is 0. The first digit, when you add 1 0 1 1, 1 0 1 1, you assume this is 0. There's no carry in. You don't carry in. That's why you assume 0. Then what I'm doing, I'm taking these 2 numbers, A and B. Understand? I made one more now. I made a 2-bit addition. I made a 2-bit adder. Now this carry out goes to the carry in, and you get another A and B. Now let us call this as a simple idea. This we call it as a A0, A1, 2-bit. And this one We call it as a B0, B1. And this we call it as a sum 0 and sum 1. And this is carry out. We draw like this, carry out. Am I right? See out. So if you give a number, for example, you want to add 1, 1 and 1, 1. You are trying to add. Assuming that you are adding 1, 1 and 1, 1. That means that this is number A. This is number B. This is A0. In number A, bit 0. Number A, bit 1. Number B, bit 0. Number B, bit 1. So I'm trying to give a generic method. Please understand, these are the one you are going to live with it for long. Nothing is required in this industry. If you go and watch the video one or two times, you will be thorough with this. And you start drawing this block. So this is become 1, 1. So this is 1, this is 1. And the B1, B0 is 1, B1 is 1, 1, 1. And this is 0 now because we ground it. And this we don't know. This we add it. When you add 1 plus 1, 1 plus 1 is equal to 1, 0. So we get 1 here, we get 0 here. So now sum gets 0. Now what is going is the 1 goes here. Now adding 1 plus 1 plus 1, that is 3. That is 1, 1. So sum gets 1 and carry out gets 1. The result is 1, 1, 0. If you give 1, 1, the result is 1, 1, 0. Understand? So if you add these two, you get 1, 1, 0. This is 3. If you convert decimal, this is 3. 3 plus 3 is 6. This is called, see, unfortunately in your college, they give you some concept called full adder, half adder and dot. Nothing. We in industry, we call only adder. We don't have anything called full adder or half adder. We have only adder. What I'm giving you is an example of adder. That's all. We don't have any concept called full adder, half adder and dot. Okay. Don't get confused them. We have only adder. So understand now. Now I add one more bit. The 3-bit adder. Now what happened? This carry will go inside. Now I have A2. I have B2. I have sum 2 and carry. So it becomes 4 bits. When you add 3 bits, 3 plus the 3 bits, you will get a 4 bit. That's why the C is there. Suppose you add a 1 more bit, 4th bit. Then what happened? This C will go here. One C out will go to the C in. Then I add here sum 3, I add sum carry, and here I have a A3 and B3. Now the thing is that you should know how to make them as a block. Now what we do here is we make all the connections internal, so we make them as this as a block. See here, this is a block. This let us draw here. See here, I draw a block now. You understand this block now. So what is inside the block? This come out, sorry, S0, S1. So S0, S1, S2, S3, and C are output. C out. And A0, A1, A2, A3 is input. B0, B1, B2, B3 is the input. This is called adder. And how many bit adder? 4-bit adder. This is called 4-bit adder. but we don't draw like this. This is quite no, if you want to add, this is a 4-bit adder. That means you have to give a 4-bit. You are trying to add 0, 1, 0 and 1, 0, 1. You are trying to add the number. Then you say, now let us assume that, let's say somebody has asked this. How do you add 0, 1, 0 and 1, 0, 1? Am I right? Now let us say this is A and this is B. And we have a 4-bit adder. What do you have a 3-bit? So you have to add a 0 here, prefix. And you add a 0 prefix. This is A0, A1, A2, A3. That is 0, 0, 1, 0. What is B? 0, 1, 0, 1. 0, 1, 0, 1. So if you have a 3-bit adder, then remove this. If you want to have a 3-bit adder, remove this. You have a sum. That's it. Okay. You add 0, 1, 0, 1, 0, 1. Okay. You add them. You will get the result now. If you get the result is 0 plus 1 plus 0, 1. And 0 plus 1 plus carry is 0 here. Sorry. The carry is 0. So remove this. So 0 plus 1 plus 0 is 1. Then the carry is 0. The carry is 0. 1 plus 0 plus 1 is 1. And the carry out is 0. So you get the answer is 0, 1, 1, 1, 1. You know that in a microprocessor, for example, if you have studied in the college, there'll be 8-bit microprocessor. You try to say that accumulator and trying to add 8-bit to 8-bit. You get one 8-bit result and the carry will be set to the flag. They call flag. The carry will go into the flag. That we will discuss when we are discussing about the microprocessor later. If anybody is wanted seriously about 8085, I've taken a classes on 8085. I have a, I can share all the things with you. You just let it know that if you want to have a 80, let's say you are in the college and you wanted to have some understanding about 8085, I can share those things to you, videos. It's all that in the Google Drive only. So this is the way it does. So you don't think we don't complicate this. We make things very simple. How do we make very simple? See here. I add like this. I put slash A, slash B, slash S, and C. We don't draw outside. We put some A, B, and carry. That's it. This can be anything, even 8-bit. Carry will be only 1. This is called 8-bit adder. If you go for a 16-bit microprocessor, then this will be 16. If you go for 32-bit microprocessor, this will be 32. If you go for 64-bit microprocessor, then this will be 64. That means that 64-bit microprocessor will add 64-bit at one shot simultaneously. That's a trick. Understand now? That's the way they perform the additions very fast. So this is one of the application. Now let us talk about links. You know one thing, they converted because of this. They made subtraction is also addition. They made subtraction is also addition. How? Let us assume that I have 9. I have 9. I have 5. I want to subtract. 9 is 1, 0, 0, 1. 5 is 0, 1, 0, 1. But I have to add. So let's not take 5. Let us take 3. That will be easy for you. So 3. So If I add them, what will I get here? 1, 1, 0, then 1, 0, then 1, 1. I get 12, but I want 6. How do I do that? What they have done is very beautifully. This is what the trick. 9 minus 3. I take 9. I take 3. Am I right? The 3 is 9's complement is 6. 9's complement is 6. 10's complement is 7. Sorry. This is 9's complement. That is 9 minus 3. Then 10's complement is you add 1 to it. It becomes 7. Now you add these numbers, 9 plus 7, 16. Remove this. You don't need this. You don't need the distance. Then you get how much? 6. Got it? 9 minus 3 is 6, but I need addition. Now what they did was, I'll tell you now what they did. That's the beauty of it. I have adder. See that I have adder. Let us take a 4-bit adder. I have a 4-bit adder. Think that I have a 4-bit adder now. And this is A0, A1, A2, A3. And this is B0, B1, B2, B3. Am I right? This is carry out. And this is sum 0, sum 1, sorry, sum 3, sum 2, sum 1, and sum 0. Now, when you have a number of 1001, that is 9, and 3 is 0011, you have to subtract. But we have only adder. We don't have a subtractor. So what we did was, we take the ones complement of this. What is the ones complement of this? 001. Ones complement is 1100. That means that what we did was, for all the B classes, we add an inverter. For all the B, we add it's very simple here. We add an inverter. Now we are given a 1001. But here you are given 0011. Am I right? Sorry, 11. When you do complement, it become, let me write it on different color. It become 1, 1, 0, 0. But other number is same. We don't change A. Now this becomes 0011. But this is one's complement. How do you make a two's complement? You have to add 1 to it. I told you there's a carry in available. Now what happened? The subtractor, they add a carry into the 5 volt. So that become 1. So they add a 1 to it. So now what happened? You add them. What result you get? 1 plus 1 plus 1 is 1. Then it become 1. 1 plus 1 is 0. Sorry, this becomes 0 now. Sorry. The 3 is a main number. See, the 0011 is a B number. A is a 1001. 9. 9 minus 3. Sorry. Top. 9. We are trying to do 9 minus 3. So 9 is 1001. Okay, 1. We write a different color. Then you know that. A 1, 0, 0, 1. Done. I don't change that. I don't change A. But B is minus 3. How minus 3? What I'm doing? 0, 0, 1, 1. I'm taking the ones complement. It become 1, 1, 0, 0. So 1, 1, 0, 0. Now what I'm doing? I'm adding now. But if I add, I don't get the right result because 1, 1, 0, 0. See that I add 1, 0, 1, 1, 1, 0 is 0. Then you leave out this. This you leave out. You get how much? 5. But 9 minus 3 is 6. The problem is this is called one's complement. If you add 1 to it, it becomes 2's complement. How do you add 2 here? There's a carry in. The first block, we add that to the 5 volt. So now what happened? We add 1 to it. Now we get 1, 1, 1, 0. I get 1. I get 1. 1. Then 1, 1, 0, 1, 0. So remove this. You get 6. So this is called, this block is called subtractor. A goes out. Same thing. These are called difference. Instead of sum, they call this as a difference. And this we call borrow. Understand now? This they call borrow. Okay, this bit they call as a borrow bit. So, yeah, adder can be converted to subtractor. See, don't get in deep. If whoever wants, see, don't get confused. I've just given you today idea of what is this. That's all. Don't get confused. I'm not telling you this for confusion. I'm telling you that what is the application of combinational logic. That's all. No, you cannot do that. If you do the ones complement, if you don't add it, that becomes adder. But you are trying to build a subtractor. A subtractor means you have to add a 2's complement to the number. How do I add 2's complement? I take 1's complement and add 1 to it. That's called 2's complement. So what is 1's complement? What is 2's complement? So 2's complement is this. If you take a number 10001101, this is 5. Now what is minus 5? Take 2's complement 0111 0010 and add 1 to it. 0111 0011. This is called minus 5. Please understand the difference between 5 and minus 5. They are not so easy as you think. Normally, what you think is like this. What you think is 5 means sign bit is 0, sign bit, and 0000101. Minus 5 means take sign bit as a 1, 0000101. No, this is wrong. This is not minus 5. You know one thing, what is minus 5? Take the 7 bits. Sign bit, make it as a 0, and sign bit, make it as a 1. Take the 7 bit here. Convert it. 1, 1, 1, 1, 0, 1, 0. That is what 1's complement. That is what inverting. Then add 1 to it. Become 1, 1, 1, 1, 0, 1, 1. So this is what actually minus 5. This is what minus 5. This is 5. In this case, sign bit is 1, sign bit is 0. What? No. For example, let us take a small case of what is decoder. We know decoder. You would have heard in the college. That is nothing but I have a 3 inputs. Let's say 2 input, 2 to 4. And I have 4 outputs. This is called, let us say A0 and A1. This is called cell 0, cell 1, cell 2, cell 3, assuming. Now what they do here is, I have 4 outputs, I have 2 inputs. The logic is when both of them are 0, 0, cell 1 should be, cell 0 should be 1. 0, 1 means cell 1 should be 1. 1, 0 means cell 2 should be 1. 1, 1 means cell 3 should be 1. Cell means select. Now, what is inside the block? Now, let me draw the block inside. It's quite simple. I have internally 4 blocks. I have internally 4 blocks. Understand? Internally, how many blocks? 4 blocks. And I have 2 inputs, A0 and A1. This goes here. All of them. This gain name is 0, 0, 0, 1, 1, 0, 1, 1. So inverter is a combinational logic, cell 0, 0, 1, 0, 1, cell 1, 1, 0, cell 2, 1, 1. This is what called decoder. But today you don't have to use that. Not required at all. These are all not required. Once you pass the exam, you don't, in the industry, we don't use these things. This is all only for the college syllabus is there. Okay, you don't need these things at all today, because we have gone to the totally these are all 20, 30 years old. We don't need them at all. But still, a lot of people are studying in the college and everything. I've just given an idea. What is the application of combinational logic? So these are all the applications. See, you are getting confused. No. Why I have given another idea is that don't get confused between combinational logic and the application of combinational logic. Oh, latest is gone somewhere. We ourselves is now about 10, 20 years old. I'm trying to give you the fundamentals so fast, so we can able to discuss the latest ones. These are the ones. We are discussing, we ourselves discussing pretty old. Now what I'm telling is, instead of spending 6 months on digital electronics, spend for 8 hours. Enough. I've reduced the 6 months to 8 hours. That's it. That's what I can do that. But the problem is, I myself has comprised the digital electronics to the small, which is required by industry. Whatever our 8 sessions, you have to be 100% thorough. You have to be 100% thorough. And I'll give a sum. I have a sum in our app. I will give it to you that. Once you solve them, if you get 10 out of 10 for the 3 consecutive days, then you understand. That's all. I have a concept. If you score 10, and this is a random, I have about some 150 questions. It will take 10 from that. Okay. Once our this session is over, digital electronic session is over, I'll give this test to you, your batch. Then whoever takes, every day you take a sum, it will be different sum. 3 days, if you score 10 out of 10, then you understand it. Till that time, you have to practice. The day till you take 3 10 out of 10s, I don't agree that you know digital electronics. That's a trick. Same thing, I have it for electrical. Okay. Once you've done the next electrical, I have the same thing. Same thing I have for electronics. Like that, we will test ourselves. It is not for me, it is for you. It is for you. Please understand. So the latest is somewhere else. I'm trying to catch that very fast. I'm trying to catch. For that requires to touch the latest, you require 3 things. Fundamentals of electrical. Ohm's law, power law. That's all, nothing else. I don't need Thevenin theorems. I don't need Wavestone bridge. I don't need Kirchhoff law, voltage, nothing. Nothing. Only V is equal to IR, only 2 formulas. Then electronics. IC is equal to beta into IB. Enough. Then digital electronics. And or not. And combinational logic. Enough. I don't need application of combinational logic. Even though I taught you today application of combinational logic, I myself say that it's not required in our industry. Then why I have discussed with you? Because you should know that how do we build the blocks using digital electronics. That's why I discussed with you. Okay, so the same thing, you have an encoder. So I have a multiple inputs. I have 2 outputs. So I0, I1, I2, I3, Y0, Y1. That's what encoding. You are encoding from decimal to binary. That's why they call this as an encoder. Same way, I have 8 inputs here, 4 inputs. I have only 1 wire. I have 4 outputs. Y0, Y1, Y2, Y3. Understand? I have a bulb here. I have a bulb here. I have a switch here. I have how many wires? 1 wire. Now, if you put switch I3, then Y3 should glow. If you put I0, Y0 should go. That is what? Mux and demux. But how do they synchronize? For that, there is a small control logic. This guy gives you 2 bits, control bits, called C0 and C1. When both are 0, internally there will be a switches, the mux. And internally switches. See here? When you make this one as 0, 0, this will be on, this will be on. So now what happened? If you take the wire, this is connected. The first wire is connected. Now, when I give 0, 1, then this will be off, and this will be on, and this will be on. Now, these two are connected. But this should be common. The control should be common for both. Otherwise, it's not possible. If we give 1, 1, and this will be off, this will be on, and this will be on. See here? Am I right? This is the way it goes. So these are all, this, as I told you now, don't get confused. I've given you the idea only. If you forget even today's class, I'm happy. You should learn how to forget things. That is, last class we discussed about combination logic. That only thing you have to remember is simple. If we give any inputs 1 0 1 1 0 1, that many inputs, gate and solve it. 1 0 1 1 0 1 1 0 1 1 0 1. If you can do that, I say that you are good at combination logic enough. This has to be understood by you 100%. Any logic, you should be able to do this. Yeah, I can go much deeper also in mux. I'll do one thing. All this adder, subtractor, mux, demux, encoder, decoder. I will give a separate videos and give it to you. So it may be useful to you. Somebody may watch it if you have a time. Because I don't need, I'm not, see, the path is that you don't have time. My thing is that you have, I can start explaining everything. But you will learn it at the age of 60. At the age of 60, you will understand. I'm 60 now. It took about 35 years to learn everything. Whatever I learned, everything if I give you, you will also take the same time, which I don't want. I want you to take you my 35 years of experience to you in 3 months, 3 to 4 months. Then you should carry away from there where I left. Otherwise, you don't make money in the industry. We don't need so many things what we have done everything in the world. See, the problem is in electronics today, 10 years experience and 2 years experience is same, because what he did for the previous 8 years, all waste. The last 2 years is only useful. So you two are useful. Please understand. That's the trick here, converting experience as expertise. Even today, if you start today, within 2 years, you will get 10 years of experience. This is the beauty of this modern electronics. The only problem is, you know one thing, what is the problem? Your mindset, which is full psychology problem. Nothing to do with the technical. Technically, it's all very simple, man. If you know this combination logic is enough, then I'll bet next session, we're going to discuss about sequential logic. That is another simple one. You'll be very surprised. Nothing to do that. Correct. Exactly. These are all, we are using these things to build actually 3 things. One is combination logic, sequential logic, tri-state logic. We built using these 3 to microprocessor. That's all. So the application of this is application of combinational logic is, gate is combinational logic. Application of gate is sequential logic. Application of gate is tri-state logic. And application of combinational logic and tri-state logic, sequential logic is microprocessor or memory or ROM or RAM. We're going to discuss all of them. Please. We are not going to leave that. Understand? We are not leaving everything. Anything. Even I don't mind. As I told you, if I have to discuss with you, I don't mind to take extra classes also. So let's have a small break. Then we will get back to sequential logic. Let's take a break now, and I'll stop the recording.